Hello, my amazing students. This is Mrs. A, and I love math. And we are back with Lesson 17 in your Algebra, Saxon Algebra Orange Book. So, if you're in that book, and that book looks like, just so you know, looks like this. Okay, this is the book that we're using. And if you're in that book, then these lessons are for you. And I'm making them, trying to keep up with my granddaughter, Hannah, who is in Algebra 1 now. And we're on Lesson 17. So Lesson 17 has 3 parts. So this is the first part, which is mostly definitions. Okay, so we're talking about factors and coefficients. And the first part of the vocabulary they were trying to teach you in this lesson is the indicated product. So the indicated product means something is being multiplied together and it's indicated multiplication. So 4 times x times y, whenever we write variables right side by side, that's multiplication. And since we have a 4 here multiplied by x and y, that indicates that 4 is to be multiplied by the product of x and y. So that is an indicated product. When we multiply several things together, it's a product. 2 things, 3 things, 4 things, it's a product. So when we have a product, the individual pieces are called factors. So in this product, we have 4 and x and y are all factors of 4xy. They're all the pieces of the puzzle. And 4 itself would have other factors. We could say 2 is a factor of 4. And so 2 would also be a factor of 4xy. So, but x cannot be broken down anymore, can it? So, and neither can y. So, they're already as low as we can get them. But 4 does have other factors inside it, doesn't it? So, we would say that 4xy is the product, and 4 and x and y are the individual factors. So, we multiply the factors together to get the product. So the second little board here is the definition of the word coefficient. So in your text, it's going through the difference between a numerical coefficient and a literal coefficient. And this is probably a little bit more information than you even need to know, because usually we use this form of coefficient that is actually a number. So we call it a numerical coefficient. So basically, coefficient 4 is the coefficient of xy. So 4 is in the front multiplied by xy. And since it's a number, we call it a numerical coefficient. X is the coefficient of 4y. So here's the x in the front and the 4y. So the x is multiplying into the 4y. So this is a literal coefficient because it's not a number, it's a variable. We will almost never use literal coefficients. So we're going to, in this textbook, we're going to only focus on numerical coefficients. So this is what you're usually going to see is terms. And 4xy is one term. It's a product. And we're going to talk about terms in the next section there. So this is a product, and 4 is the coefficient on the front, because we're only going to talk about numerical coefficients. This is the product, and negative 15 is the coefficient on the front. 81xmz is the product, and 81 is the coefficient. So when we hear coefficient, we're going to think numerical coefficient. Like I said, this other information is maybe just a little bit more than you actually needed to know, but it doesn't hurt you to know it, that there are different types of coefficients. We're just going to be working with numerical coefficients in this textbook. And now we'll go to section B. Okay, this next section, 17B, is all about terms. What are terms? So a term is an algebraic expression, and it can be either a single variable or constant, or It can be the indicated product or quotient of individual variables or constants. Or look my little caret here, it can be the indicated product or quotient of expressions containing individual variables or constants. So it is basically a very broad definition. It could be 4, or it could be x, or it could be 4x. So this was definition 1. These were definition 1, where it says it is a single variable or constant. But then that little second one there was a product of individual variables or constants. And then the third one was broader. It said it could be an indicated product of expressions. And here we have a product and a quotient. So this whole thing was a big quotient, isn't it? So this was products up here, but then we put it all over P. So now this is one term. Okay, and then down here we have a one term, because isn't that a quotient all over one denominator? And that's one term. Okay, so a broad definition that works is a term is a single entity that represents or has the value of one particular number. Okay, so knowing what a term is allows us to kind of represent individual parts of a larger expression. So here we go. For example, if I have this long expression, I have 4 terms. X is the first term, 4xym is the second term, negative 6p over y plus 2 is the third term, and negative 8 is the fourth term. The terms are always going to be separated by plus and minus signs. Now, we have a little conundrum here. We cannot assume that negative 6p over y plus 2 is always going to be negative, even though it has a negative sign in the front, because it is going to depend on the value of p and y to determine the value of the expression. But negative 6p over y plus 2 is the third term, and so we can refer to the third term without having to copy it down every time, and it makes it very convenient. So now let's discuss this briefly. It can be a negative value or a positive value. So the sign of the number will depend on the values of p and y. So let's let p be negative 2. If we let p be negative 2, then negative 6 times negative 2 would be positive 12. But we still don't know the final value of the number because we have this y down here. What if we made the y a negative 14? Then I'd have a positive 12 over a negative 12. My answer would be a negative 1. But if I made that y right there be a 4, then I'd have a negative 12. No, that's a positive 12. Positive, because I'm letting the p be a negative 2, so positive 12 over a 6 would be a positive 2. So the value of the expression is always going to depend on the values of the individual variables, and the sign is included in that wishy-washiness. So now we're going to move into a very fun property, the distributive property. Now we've already talked about the commutative property, And the commutative property for addition simply means that it's okay for two numbers to commute or move, and it doesn't change the sum at all. So 3 plus 8 is the same thing as 8 plus 3. So the order that I see the numbers in does not matter as long as the operation is addition all the way. So I could really mix it up, and I could say 2 plus 3 plus 4 is equal to 4 plus 2 plus 3. So now I mixed them all up, but I have the same numbers and it's still addition. So 2 plus 3 is 5, plus 4 is 9. And then 4 plus 2 is 6, plus 3 is 9. And I still get 9 either way I do it. For multiplication, it simply means that 3 times negative 5 is the same thing as negative 5 times 3. And it is. Okay? The distributive property, which we're coming into, says that if I have a number or variable multiplied by the sum of two other numbers or variables, then that is equal to the coefficient in the front, which is the a here, times the first term, so a times b, plus the coefficient in the front times the c, which is a times c plus ac. Right, so remember we have numerical and literal coefficients. Here, right now, this would be literal, wouldn't it? It doesn't have a number, but this is a formula, and it could be either a variable or a number, and we could call it a coefficient. So AB plus AC. The A is multiplied by the B, and then the A is multiplied by the C, and they're added together. Okay, so let's see how this works. So let's look at your first little, it's not one of the examples, but in the part of the teaching section, it says 4 times 5 minus 3. Now remember, subtraction is just addition of the opposite. So as long as we are keeping, we're not using the commutative property, we're not moving these back and forth, we're using the distributive property. So 4 times 5 is 20. And then 4 times, we can put the minus in the middle. 4 times 3 is 12. And so we're going to 20 minus 12 is 8. Now, don't get confused. What would happen if instead of a minus 3, I put plus a negative 3? And then I said 4 times 5 is 20 plus 4 times negative 3. So now the negative is going to go right there. And I'd have 20 plus a negative 12. And isn't 20 plus the negative 12 the same as 20 minus 12, which is 8? But what if I did it the other way? What if I did this in here, did the parenthesis first? 5 minus 3, or 5 plus a negative 3 is 2. 4 times 2 is 8. Well, that's much faster. We'll use normal multiplication if we can, because it's faster. But it's not always going to be numbers in there. What if I had a plus 4? I can't add a and 4 together. Now I have to use the distributive property. I have a choice of using the distributive property when everything is a number. And I could see that when it was a 5 minus a 3, I could see that that was 2, and 4 times 2 is 8. But we're using this because you can see that it works. Okay, 4 times 5 is 20. 4 times a negative 3 is a negative 12. 20 minus 12 is 8. We can see that it works both ways. But we're not always going to have numbers there, and that's why we have to have the distributive property. If it's like this, with 4 times a is 4a, plus 4 times 4 is 16. And we can simplify it even though we can't add these two together. So we're going to be doing a lot of that, but we usually won't be doing it. We won't be using the distributive property if we have the numbers available. We'll just add the numbers or subtract the numbers and make it a little bit faster. All right, so let's look at this. The distributive property, we can expand it. So we can extend the distributive property out more than just two things in here. So we're going to use the distributive property 4 times 6. Now remember, I can use the minus in between, and then I don't keep it on the 2. Okay, plus 4 times 5 minus 4 times 7. Okay, so let's explore this a little bit. So if we just did it this way, I kept the minus in the front, and I kept the minus in the front, and I brought down the plus sign. 24 minus 8 plus 20 minus 28. Okay, so 24 take away 8 is going to be 16. And then 16 plus 20 is 36. And 36 take away 28 is 8. All right, so now that was using the distributive property. Now let's just do everything in the parenthesis first. 6 minus 2 is 4. 4 plus 5 is 9. 9 take away 7 is 2. 2 times 4 is 8. That would have been much faster, right? So my general rule is if I have all numbers in here, I'm going to do it using just order of operations. Do what's inside the parenthesis first and then multiply. That's what I would do. But we have the distributive property because we don't always have numbers, and we need the distributive property. If that were an A, then we'd be in trouble, and we'd have to use the distributive property. But they're using it now to show you it works so that you can actually do it 2 different ways and get the same answer. All right, so here we have variables. We have to use the distributive property. So we're going to say mn times x plus mn times y plus mn times 2p. Usually it looks better if we put the number in the front. So 2mnp. Does the order of those variables really matter? It doesn't. Okay, so let's look at the second board here. Okay, this is example 17.3. So now notice we have the multiplier, or in this case, it could have been here, right? So we could call it the coefficient. It's just in the back instead of the front. But we're still going to do the same thing. MP times x is MPX minus 3y plus xzmp. Oh, and I ran out of room. xzmp. Okay? Now, it doesn't really matter which order the variables are in. Some books you'll see more of a convention. They'll put them kind of in alphabetical order. But, really mathematically, it does not matter. Okay, so let's use this one. And there's no way we can simplify that, is there? We can't add any of them together because they're not like terms. Okay, look at this one. We cannot add 2x minus 4 together. We have to distribute. So we're going to have negative 3 times 2x is negative 6x. Negative 3. Now, remember, if I bring the minus sign down, then I have to make this a positive 4. And I'd have 4 times a negative 3 would be a negative 12. And then I'd have a minus a negative, which would be a positive. I'd have negative 6x plus 12. That's one way to do it. Or I could just not worry about this. And I could say, I'm just going to, in my mind, change this. I'm going to attach the minus sign and call this a plus sign. So basically, it's the same as plus a minus 4. It's exactly the same thing, whether I have the minus in the front or whether I attach the minus and put a plus here. Subtraction is addition of the opposite. All right, so now I get negative 6x, and negative 3 times negative 4 is positive 12. To me, that's faster. But you can do it either way because they're both correct. Okay, so now down here, we have a good example. We're going to do the same problem, and we've already done it, same one we did at the beginning here. Do the same problem using order of operations, which means we always do what's in the parenthesis first, and then we take care of the rest of it. And then we're going to do it using the distributive property, and we should get the same answer. So here we go. We're going to do the order of operations. 5 minus 3 is 2. So 4 times 2 is 8. Okay, so now we're going to do it using distribution, which means 4 times 5 minus 4 times 3. I should have written it out, but I forgot. So 20 minus 12 is 8. And I get the same answer either way I do it. Almost done with this lesson. C in your practice problems was to use A, B, and C to demonstrate the distributive property. Well, we're going to have A times B plus C is A times B plus A times C. Okay, so I'm demonstrating the distributive property. Would it matter if I made that a minus and that a minus? It's still the distributive property, isn't it? Okay, so here they tell me to use the distributive property instead of order of operations. So it's going to be 4 times 6. Okay, so minus 4 times 2 plus 4 times 5 minus 4 times, doesn't matter whether they have that there or not, minus 4 times 7 minus 4 times 7. There. So 4 times 6 is 24 minus 8 plus 20 minus 28. And that was 16, and that's a negative 8, which is 8. Okay, now remember, I could have made this a positive and that a negative. I could have made this a positive and that a negative. And guess what? I would have gotten the same answer. Exactly. Last board, and then you get to work on your homework. Okay, we cannot use just normal order of operations here. We have to use the distributive property because we cannot add or subtract these two terms. So we're going to have 2m times xy, and then 2m times a negative 3p. Right, so I can attach that minus sign to it. 2 times a negative 3 would be a negative 6. So minus 6mp. And that does it. xy times a, xy times b. I'm going to put the number first, minus 2 XYC. We always put the numerical coefficient in front. So now, would it matter if I said AXY plus BXY minus 2CXY? Not at all. These are both correct. Does not matter at all. We are done with lesson 7. But you're not done. You get to do your homework. And this is Mrs. A. And may God bless your day.